I'm pleased to introduce Gangesh Ganesan, President and CTO of Peernova. Mr. Ganesan has over 2 decades of distributed systems experience with his former companies acquired by Twitter and Qualcomm. You've got the floor, sir.
Thank you. Thank you, everyone. It's genuinely a pleasure and honor today to be in front of all of you to just kind of give you a brief introduction about Peernova. But I'm going to take most of the time to talk about sort of applications for blockchain, more generically, applications that can be used in financial industry. So Peernova is a company basically about building blockchain applications, and the idea is to store, secure, and validate data primarily for financial institutions. It's a quick view into our executive team. Immediately before this, I was actually doing a streaming analytics company, and for those of you that are sort of familiar with how Hadoop works, Hadoop and all the other big data systems are mostly about what we call batch analytics. And 5 or 6 years ago, doing streaming and real-time analytics in Hadoop was sort of a new thing. We were exploring some ideas on how to do streaming analytics, and eventually ended up selling the company to Twitter. Post that, I was looking for some ideas on what to go do. IoT sounded like a very interesting area, and security sounded like a very interesting area. And in 2013, that's when I ran into the Bitcoin white paper. And the paper was so interesting that we thought, maybe one way to learn this new technology that is being promised by this white paper is to start a company. And very quickly, we started a company. We just didn't even know what to do. And the only thing that was available for us to learn at this time was to mine Bitcoins. And we started mining Bitcoins, and it was sort of initially a small hobby. We mined a few coins. We ended up getting really, I would say, addicted to it. In a brief period of time, we were buying more and more machines, and in a period of about 9 months, we had ended up with 6,000 mining servers. We had a little over 10 megawatts of power that we had in contract. Some of this power was in Iceland, some was in the Pacific Northwest in Washington State, some was in Texas. We mined 47,000 Bitcoins within a brief period of time. And the business model was this. We were basically trying to say, hey, there's a market for mining Bitcoins itself, and why don't we offer that as a cloud service for people? Prior to that, people would go and say, let me go buy a mining rig. And they would try and install this at home and buy mining rigs this way and mine Bitcoins. When the network computing capacity was pretty low, this was actually possible. But one of the problems was, as ASIC-based miners came along, it was very hard to get one of these machines. So people would pre-order them and would wait for 3 months, 6 months before these machines showed up. So the business opportunity we found was that we could buy these machines at scale. We would install them in a data center, and then we would let people come and mine these coins using the service. So instantly, once they pay for the mining rig, they would be able to provision it on the cloud and be able to mine immediately. The coins that were mined in the cloud would be automatically deposited into their wallets. So this service allowed us to build a very, very large mining network. We were one of the largest mining networks in the world. We had about 7% of the total Bitcoin mining capacity at this time. What this gave us was an opportunity to, A, understand Bitcoins, understand how the Bitcoin wallets worked, how the system worked, how the distributed system actually functioned, what the various components in this distributed system were. Now, as we ran a lot of this, our original intent at this time, and Bitcoin price was wildly volatile. It was $10, it was $1,000, it was $300. It was very, very volatile. Now, as we ran this network, we had an opportunity to talk to some of the largest financial institutions in the world. As we went and talked to the financial institutions in the world, we realized that there may be a bigger opportunity, at least for us, in actually building a software platform using some of these technologies. Now, we didn't quite know yet what these software technologies at this time would be in 2013. This was prior to the existence of projects like Ethereum. Now, if you go and talk to people today and ask them, what is it that's interesting about Bitcoin and blockchain, you will find people giving you different answers simply because Bitcoin and blockchain have many different aspects and facets that are interesting. Some people will talk about immutability. Some people will talk about eliminating trusted intermediaries in transferring value. Some people will talk about it as a decentralized protocol using P2P ideas. Some people will talk about cryptographic identity management. Yet others will talk about tokenization. I have a list of features that are listed here, all of which are properties of Bitcoin and blockchain. In fact, it's very difficult to describe Bitcoin and blockchain in a single sentence simply because it includes these and probably other aspects. Right? Now, because we ran one of the largest mining networks in the world, we had an opportunity to go and talk to some large financial institutions. And as we talked to these financial institutions, we found out that these were the problems that they were most interested in. The problems listed on this slide describe things about exception processing and workflow automation. Okay? If you go to a financial institution, you look at hundreds, thousands of people who are actually handling exceptions. These are people in middle and back office who are doing reconciliations, who are doing error management, who are actually figuring out how to make the financial plumbing work in an automated way. And much of financial plumbing is automated, but there's a lot of exceptions to the automation. And so if you talk to a financial institution today, they'll tell you these are the types of problems they're looking to solve. All of them are looking to solve risk-related problems. Since 2008, the risk-related problems are actually mandated by Federal Reserve and some of the regulatory bodies. So people spend hundreds of millions of dollars every year in risk-related systems, every single institution. Audit and compliance, as we know, is one of the most expensive functions that most financial institutions perform. Lastly, one of the most important spends in a large financial institution is all about cybersecurity. So if you go to a financial institution, this is the list that they talk about, while the list that I showed you in the prior page is what is sort of interesting about Bitcoin and blockchain itself. So how do we actually reconcile these two lists, and how do we actually understand what is it that enterprises are actually looking for, or particularly large financial institutions are looking for when it comes to building blockchains, distributed ledger platforms, whatever these technologies are offering? These are some of the things they're looking for. Clearly, they're looking for what they're calling enterprise quality. And within quality, there are lots of buckets. It might mean scale, it might mean tools, it might mean actual quality, meaning bug-free, nature of it being very flexible, lots of different stuff. The second thing that financial institutions are talking to us about, and tell everybody literally about this, is that how do I use this technology? I already have legacy financial infrastructure in place. In fact, most financial institutions have legacy systems that have lasted them for 30, 40 years, and some of them, they've been building on top of it with newer technologies in the last 5 years or so. So they'd like to know how exactly do you apply blockchain technology to this existing legacy infrastructure. The last thing is to understand who the true real middleman is. What do you actually mean by when you say eliminate the middleman? Who are you actually trying to eliminate? And mostly, if you go talk to large financial institutions, they'll say it's about eliminating our middle and back office functions. Because middle and back office functions in a large financial institution don't really add value directly. They are needed as part of doing business, but clearly they want to reduce that cost and that layer. And that's really what they're looking to do. So if you sort of now step back and look at, okay, what exactly does a financial institution look like? I keep talking about this front, middle, and back office. Front, middle, back office is a hypothetical sort of partition of what a financial institution itself looks like. Now, if you sort of break it down and say, what exactly is in a front office, what's in a middle office, what's in a back office, this is a representative view. Not all institutions will exactly follow this view, but this is a pretty good view that we've actually gathered from talking to tens of financial institutions literally around the world. Front office typically consists of things that have to do with their orders and order processing. It's mostly associated with transaction systems, potentially algorithmic trades, what they're called modeling systems that do automated trading, market surveillance, pricing. These are some of the things that are part of a front office system. A middle office system consists of things like order consolidation and netting. Okay, for those of you that are interested in knowing what netting is, I might have an order for going and buying Apple shares. Somebody else, another client, might also give me an order for going and buying Apple shares. So I might actually consolidate those two orders and go and execute a single order out in the market rather than go and do two separate orders. That's an order consolidation. That's an example of an equities order that I'm giving an example of now. Consolidation might work in various different financial instruments in various different ways. Risk itself is part of the middle office functionality. Back office consists of functions like reconciliation, clearance and settlement, internal and external audit, corporate reporting. Now, if you look at this type of a view into the financial institution, what it also tells you is that each of these front, middle, back offices, the actual applications are not single applications. So it's not like the front office has a single piece of software that they call a front office software. The front office software itself consists of probably hundreds of applications, in some cases thousands of different applications, depending on the actual use case. Similarly, middle and back office consists of lots and lots of different applications. Each of these applications actually have their own databases, have their own data stores, and is extremely complicated in terms of how they message data across all of these different applications. In fact, when you look at a particular trade event in a particular bank, and try and see how it actually ends up as a consolidated book entry. Let's say I'm a bank, I'm Citibank. I have a trade request that comes into me, to Citi, from a corporate client to go and say, buy Apple shares. How does this eventually turn into a consolidated book entry into the financial institution? Well, the trade enters the front office. It eventually makes all the way into the back office and becomes a consolidated book entry on their book of records. But before it actually ended up as a consolidated book entry, it went through literally hundreds of applications inside front, middle, and back office. Some of these applications involve enriching the trade data, may involve aggregating the trade data, may involve netting the data, may involve adding risk scores to the data, various other transformations. Some of these transformations are done inside the financial institution. Some of these transformations are done outside of the financial institution. You may actually have to go record something at DTCC. You may have to go to a custodian and grab actually the actual asset. You may have to update accounts either at DTCC or at the custodian or at both places. So lots of different third parties are also potentially involved in a trade flow by the time it starts from the front office and ends up at the back office. What Peernova has done is actually model this whole event as a blockchain. And if you think of a blockchain and a Bitcoin transaction, for those of you that are very familiar with Bitcoin, Bitcoin is not a typical token. When you hold a Bitcoin, you're essentially not holding kind of sort of a direct token in your pocket. What you're actually holding is what we call an unspent output from a prior transaction. So that prior transaction is linked to your transaction. In fact, that prior transaction is linked to yet other transactions. In fact, what you're holding as a Bitcoin has a lineage or a relationship all the way to the very first event that happened in the Bitcoin network when Satoshi actually ran this whole thing. So every Bitcoin transaction that you have is linked all the way to the original Genesis transaction. Now, what we've done is essentially use that same model, and we actually call it event lineage. And in event lineage, what we're saying is any consolidated book entry that you're making in the financial institution is going to be a cryptographic link of events all the way to the front office trade that came in. And so what this allows a financial institution to do is, from an operational perspective, they can actually truly understand in real time what's actually going on inside the institution. Or from a regulatory and compliance perspective, given a book entry, how did this order actually happen in my system? So you can actually model this whole thing. To do this, we essentially created an automated tool for creating this lineage. In fact, these types of lineage type applications are not native to the current blockchain implementations that we see, either in Ethereum or in Hyperledger. So we essentially had to create a domain-specific language. We call it the LDL, the Lineage Description Language, which allows you to model relationships inside a financial institution that lets you connect all these events using a blockchain. And then you can either ask operational questions on it, or you can ask regulatory compliance questions on top of it. Now, what's the benefit of doing things like this? Well, the benefit is that if inside a financial institution you already have hundreds of applications and you have a unified view of data inside a financial institution, now when multiple financial institutions are interacting with each other, it's much easier to connect the data. So when you see all these blockchain experiments happening where Credit Suisse is working together with HSBC, you actually think of HSBC as a single entity. But HSBC or Credit Suisse are not single entities. Inside Credit Suisse, there's literally hundreds of entities, thousands of applications that make up that entity called Credit Suisse. So if you can integrate all the data inside Credit Suisse first, it is much easier when you go across and create network of integrations across multiple parties. So when you integrate it across multiple people like this, you essentially can create automated tools for things like reconciliation. And if you remember, I started off my talk by saying middle and back office function simplification is the goal of most financial institutions. In fact, they don't want to write new middle and back office software, but they're forced to write it as new compliance rules come in, new risk rules come in, new operational requirements come in, or new financial instruments are created. They keep overlaying new software on top of existing software and make their systems more and more complex. So the vision here is, how do you connect all of their data with one source of truth and then allow them to connect multiple institutions together? Now, we realize that it is very difficult for financial institutions to actually do this themselves. So we actually started building tools that would automate this. So in the Peernova platform, we can actually connect to existing legacy systems in the financial world, particularly a large financial institution, let's say like Citi, JP Morgan, Credit Suisse. We can ingest data from their legacy systems and automatically build these lineages. Ideally, we are actually trying to build a tool that would learn and understand exactly what these relationships in the data inside a financial institution is, and similarly, what the relationships in data across financial institutions, so that you can automate the process of building these blockchain-like structures as you go along. So what exactly it is that Peernova does? So to build this, Peernova didn't start off by taking an assumption that the distributed ledger technology that was originally invented for Bitcoins is applicable for this market. We understood that there's a lot of aspects of that technology that make it very, very interesting, but you have to take the aspects of the technology that are relevant for the problem you're solving. So we have taken aspects of the technology that are very relevant. So the phrase we use is that we are blockchain inspired. So we take ideas from blockchains and distributed ledgers, combine it with traditional platforms that they're using, big data and cloud applications, and build our entire software stack on top of it. In fact, our software stack consists of three key features. One, we offer immutability of data. We offer immutability without doing proof of work and mining, simply because that's not the requirement for these kinds of applications. So we use an alternative technique for mining, for doing immutability. And it's a cryptographic technique called widely witnessed evidence. And in fact, there is a networking RFC for it. For those of you that are familiar with how networking works, how TCP/IP works, much of this is standardized in the world using standards called RFCs. Every industry, every company comes out and publishes the standard as an RFC, and everybody else adheres to these same standards. So this one is actually based on an existing internet standard that allows you to create immutability using this technique. The second one, broadly, the industry calls it as zero-knowledge proofs. Our entire architecture supports zero-knowledge proofs. What this allows you to do is take partial sets of data and verify and validate that partial set without revealing the rest of the data. So with a partial copy, you can actually validate the entire copy. The last one is, how do you actually guarantee that the logic itself can be actually verified? So much of what we talked about is lineage, and how we actually infer lineage comes from this core idea. So this is a big picture view of our stack. Again, if you look at the stack the way it's laid out, the bottom layer is our cloud layer. It allows us to deploy in any cloud, private cloud, public cloud, or even a hybrid cloud environment as a financial institution or as a group of financial institutions require. On top of it, we have a big data stack. Our stack runs on Apache Hadoop and Hadoop-related products primarily. And on top of that, we provide the blockchain-inspired layers and the additional services that are provided. All of these tools are today available in open source, and they're tools typically that financial institutions around the world are already using for their existing applications. So another view into our software stack, the type of applications we focus on, how do you operationalize their trade data and provide real-time insights into them? How do we provide cybersecurity resilience using these kinds of applications? How do you do applications like Sheltered Harbor, which are new cybersecurity requirements for large financial institutions? How do you do data retention, particularly for compliance and regulatory reasons? How do you have multi-party shared ledgers across multiple financial institutions? How do you generate compliance reports automatically without having to write manual code? So these are the types of applications that Peernova offers to our customers. All of it provided in the form of API and in a UI tool that we provide as our value add on top of it. If you look at the type of applications we focus on, we typically focus on applications that are run by folks in operations, risk, and compliance. And very specifically, these are some of the applications that we've been productizing over the last 3 years. In fact, in 2018, we'll be making a few announcements with a few large customers. Some of our customers are going to be in full production here in 2018. One of our first customers would be doing many trillions of dollars of transactions using our blockchain platform. We hope to come in and talk to you more about our applications. We have a booth up in the booth area, and happy to take any questions and do some demos and show you how our actual platform works. Thank you.